Are you guys excited about your machine learning powered future, or are you petrified by it? Do you believe that machine learning is going to transform IT operations, or is it going to be another in a very long line of overhyped technologies that will soon pass quietly into the night and leave operations virtually unchanged? These are important questions that we need to answer, because the one thing we can agree on, regardless of where you land on the spectrum of those questions, is that things are changing. There is a lot of change going on, and you need to understand what's changing, what's happening, how it's going to impact you, and most importantly, what you can do to be prepared to adapt and to take advantage of these changing times. As Justin mentioned, my name is Charles Araujo, and I want to start by telling a little bit about me, but let me get this on the table right now. I am not a machine learning expert. My expertise is really on the organizational dynamics of how IT organizations deal with transformation, deal with change. And I've been studying this in the context of both IT transformation and now digital transformation for a number of years. And I've been focused on artificial intelligence and machine learning for a couple of years because of its transformative impact. But before that, I was you. I sat in your seats. I ran technical operations for about $1 billion healthcare firm about 20 years ago. And I've spent most of my time since advising both IT and business executives on their transformative journey. And it's kind of led me to this point of trying to really understand how all of you are grappling with this massive amount of change that is affecting all of you today. My day job, so to speak, is that I'm the principal analyst with an industry analyst firm called Intellix. We focus on what we call agile digital transformation, and that's fundamentally anything that we consider disruptive affecting the enterprise. I also am the founder of an organization called the Institute for Digital Transformation, which studies this impact, organizational impact on IT organizations and now business organizations in the midst of all this transformation. I'm also the author of 3 books. You can go look them up if you're interested, but it's all falling around the same idea. As I mentioned, I ran technical operations back in the day, and the reality is that I mean, I don't know how else to say this, so I'll just put it out there. I'm glad I don't have your jobs today. I was giving a speech in Saudi Arabia a few months ago, and it was a mixed audience, and I asked how many people here were CIOs, and a bunch of them raised their hands, and I said, now who wants their job? And it got a big laugh for 2 reasons, because no one wants to admit they want their boss's job, but the other reason is that the reality is that almost nobody wants the job anymore, because this is getting so complex. I mean, back in the day when I was running operations, when we talked about an N-tier architecture, the N was measured in single digits. We weren't, I mean, it was, 3, 4, 5 tiers, like, ooh, you're advanced. Now, I mean, you saw the diagram in the keynote today. These application infrastructures, the structures of the technology stack are so complex that in most large organizations, there in fact is nobody that actually understands how all the stuff works together. Not one single person. And so this is not your dad's IT operation or your granddad's or grandmom's, whatever thing you want to put in there. This is a fundamentally different way in which we need to operate from, frankly, even a few years ago. And I think, so let me ask a question. Who here thinks they know what machine learning is, or maybe you're already even applying it to some degree? See, we spend a lot of time in the industry talking about what machine learning is, but I actually think that's the wrong question. We need to be focused instead on the why. Why does this matter? And Nancy in the morning breakout, if you happen to catch it, alluded to this. And the why is answered because there's a couple of key changes, 2 new rules, so to speak, for operations that are driving the why. The first is that complexity is good. Now, maybe not for you, but for the business, complexity is good. So not too long ago, certainly when I was in your seat, but as I've been advising organizations in the very recent past, we were talking all the time about consolidation, rationalization. We were trying to take complexity out of our infrastructure on a routine basis. Some of you are probably going through that now, and frankly, there's still a lot of need for that. You do not need 4 ERP systems in your system, or God forbid, 20 of them, right? But what has been a fundamental shift is that the complexity is now becoming a source, in fact, one of the few remaining sources of competitive advantage and differentiation in the marketplace. As we look at the market as it is shifting out there, it is in fact technology that is driving and is one of the few remaining sources of competitive advantage for your organizations. But it's not really technology in and of itself. Having a better ERP system isn't going to provide you advantage. It is the ability to do two things: to mix proprietary business processes with proprietary data in a way that creates value for your customers that is unique to your organization. And if you were to break down how your organization actually creates value in your marketplace, whatever your industry is, I think you will find that it comes back down to those same 2 building block components: proprietary data in some form and a proprietary way in which that data is applied to either enhance the customer experience, to transform the customer journey, to somehow provide value that is unique to your organization. And that means that maybe unlike in the past, where we would go through these peaks and valleys, we would get these complex surges, and then we would rationalize and centralize and commoditize, and then we would kind of hit a new normal, and then we'd do it again. Complexity is the new normal. We are not going to get back to a point where this is manageable in the traditional way. And this is the challenge, because as much as we have new tools, and as much as we have new ideas, and certainly lots of new buzzwords, the reality is that most of the way that IT operations is done today in enterprise organizations, quite frankly, looks exactly the same as when I was running it 20 years ago. So there is a need for a fundamental shift, and that's the second part of this. The second rule is really the other part of what's driving this, and that is that the key driver of operations in the future is data. And this is actually not unique to operations and not unique to IT. This is the key driver of business going forward, is data, because it's the ability to find and harness that data, and data is contextual, which means we need gobs and gobs of it. And so when you put these two together, you realize that pretty quickly the traditional mechanisms by which we managed IT operations simply become untenable. They won't work. We cannot keep operating the same way and hope to find success. So the question is then, what do we do? How do we respond to that? And the industry's answer right now is this: artificial intelligence, machine learning specifically. And the question is it our savior? Is it going to be the thing that makes all of this work? As I said, I was a consultant for many years, so I'm going to give you my standard consultant answer. It depends. Maybe. The reality is, I think absolutely it's going to be a key part of that solution, but it's not the panacea. There is no such thing as a panacea. We're going to get into this, that technology by itself does not solve this problem. But I do believe it is going to be a key part of this solution. And so in order to address that, we need to make sure that we are understanding what this even means. So let me ask this question. When I say AI or artificial intelligence, do you guys immediately associate machine learning with that? Do you guys get that, right? I mean, that's because the very first thing is some people don't even understand that these are connected. We're going to talk about that in a second. But I want to start by giving just a little quick, we'll call it an abridged history of AI. I'm not sure if you can read this entirely, but this is an article. And so if you get the deck, you can click this link. If not, write this down. If you want to get a great kind of crash course on AI, true AI, read this article. It is mind-blowing, eye-opening. But here's the big takeaway, is that we talk, as an industry, we talk about AI, artificial intelligence, like it's this one big blob. But the reality is that most of what we're talking about today is something called ANI, artificial narrow intelligence. And then all the stuff you read in the paper or the stuff you see in the movies, everything that Elon Musk is going crazy about right now, is all about something called AGI, artificial general intelligence. And we talk about these as if they're the same thing, but they are wildly different. I mean, they're based on the same underlying concepts, and there's an evolutionary path between them, but they are very, very different. And so when we talk about AI, we have to kind of separate the today fact from tomorrow's, I don't want to say fiction, but tomorrow's whatever that may be. Depending on who you ask, depending on which expert you talk to, AGI, artificial general intelligence, which machines start completely replicating the thinking capability of a human, is at least 10 years away. Many experts are saying more like 40 to 50 is realistic, and there are some that say it's never going to happen. I don't pretend to know the answer to which it is, but here's what I do know. It doesn't matter to us. When we talk about AI, what we're talking about is ANI, Artificial Narrow Intelligence, and ANI is artificial intelligence that is applied in a very narrow band to solve this very specific problem with a predefined outcome. And that means it's never going to morph into Armageddon, robot Armageddon, right? And so it also means, though, that this is the things that we need to be tackling today, that we need to be focused on the today problems that ANI can help us solve. So that's things like Alexa and Siri are certainly fall into that category, as well as everything else that you're hearing that is slapping the machine learning moniker on. So when we look at this in context, what we need to understand is that AI is this general category of technology, right? So artificial intelligence is this big bucket. And within that, we have a whole bunch of different approaches, different styles or ways that we solve problems within the AI space. So machine learning is simply one of those. Deep learning is another form. It's actually a subset of machine learning. Also, if you've heard of natural language processing, where we can talk and the computer can understand your words, that's a form of AI. And there's a whole bunch of them, and new ones are being developed right now as data scientists and artificial intelligence specialists are trying to come up with new ways to solve these problems. And so we need to understand it in context, right? That it is simply one way of addressing this idea of artificial intelligence. Machine learning, and I'm not going to get into a whole lot of details of exactly what it is, but let's just at least frame this. Machine learning is fundamentally about pattern matching, about identifying patterns and using it to either derive an insight or predict behavior, or predict a future outcome. And it's effectively the same thing that we do as humans instinctually every single day. That if we take a set of data, and for instance, if I walk up, well, I'm not going to, that we look at any set of pattern, any data, and identify a pattern in it and say if A happens and B happens, that means C is likely to happen. Machine learning at its core is doing nothing more than that. It is looking at the data, identifying those patterns, and saying, based on this pattern, this is what is going to happen. And then based on that, you can either drive an insight, take a next best action, do whatever you want with that. At its core, that's what machine learning is. And so the question is, then, how is that being applied? Well, you guys have heard the term supervised learning or unsupervised learning? So the reason is that for machine learning to work, it needs a couple of things. First, it needs data, lots and lots of data. Now, we again have been doing this instinctively since the day we were born. We've been collecting that data, and everything that we do on a day-to-day basis is effectively processing that data, identifying patterns, and saying, oh, I know what's then therefore going to happen. The problem is as we get into very complex systems, and by the way, for those of you that are in operations, this is what you do every single day. You are already doing this type of work, where you are seeing alerts happen, and you are connecting the dots and identifying a pattern and saying, therefore, I know that this is going to happen next. Right? All that technology, all this machine learning technology is doing that for you. So the other element of it, though, is it's identifying patterns that maybe you wouldn't see because the data explodes. We have trouble identifying those patterns. So the supervised learning or unsupervised learning is the question of how we actually train the machine to see those patterns. Supervised learning is this idea that we are teaching the computer by giving it a data set, a very large data set, and telling it, here's the outcome we're looking for, therefore here's all the data to identify the patterns that lead to that outcome. So a simple example would say an incident. If we're trying to automatically categorize an incident, we can give it a whole bunch of data that has completed incidents that have been properly categorized with all of the transactional history of that incident. Machine learning will then process all the data, identify the patterns, and say, oh, whenever I see A and B and C, that means it should be categorized this way. And then over time, as you refine it, as you tell it that's right, that's wrong, it learns. And that's the fundamental basis of supervised learning. So there's good and there's bad in that, right? Supervised learning allows us to target machine learning to come up with the outcome that we are seeking. The downside is, you guys heard of AI bias? You guys heard that in the news now? There's a lot of talk right now about AI bias. Now, it's mostly talked about in the context of societal bias, like racial bias or sexist or whatever. But that exists in everything we do, right? Because anytime we give a machine learning system a data set, we are telling it that this is the truth. And so inherent in that is any bias that we might have, either visibly, meaning because we are doing this purposefully, or that we don't even understand. So if there's a certain way that you always fix your systems, the way you always respond, and that is reflected in the data that you give to a machine learning system, it's going to reflect that bias in its predictive response. Now, that may be what you want, but it might also not be. Unsupervised learning takes effectively the opposite approach. Unsupervised learning is saying we're not feeding it data. We're simply feeding it a data set and saying this is the truth. We're giving it a gobs of data and letting it mine that data to identify patterns on its own. Now, this is a harder problem, and it can take a lot longer to get to any meaningful result. The good news about it, however, is that it can sometimes identify a pattern or an outcome that we didn't even think about. So it helps us overcome the bias problem because we are not preconditioning it with data saying this is the truth. But it needs even more data than supervised learning. It needs mountains of data, and it can take a lot longer to get there. So there's no right answer on if you want supervised or unsupervised learning when you're looking at these systems, but it's important to understand the difference and to understand how they fit together as you move forward. The big message with all of this, however, is that that's also not the whole story. See, in all the talk that's in the press about AI, in fact, last year, at the beginning of 2016, the World Economic Forum put out a big report that got a lot of press about the impact of AI and automation on jobs, and they predicted a very significant job loss in the next 5 years driven by AI and automation. And so there's been all this press about, oh my gosh, this means all these jobs are going to be going away. And I actually believe that while that may be true at some point in the future as we start approaching the AGI thresholds, right now that is not what AI is about. In fact, I think you need to reframe the term AI and stop thinking about it as artificial intelligence and really start thinking about it as augmented intelligence. That the organizations that we see, so putting on my analyst hat for a second, the organizations that we see that are really fundamentally shifting how organizations, how their clients are changing the game, are changing the way they go to market, are shifting business models, are the ones that are helping their employees make better decisions, faster decisions, and harness the expertise and the knowledge that is already captive within the organization and deploy it at the point of decision making. So it's not about replacing you or any workers as much as it's about making you more effective and better at your job. Because if we think about what we do, and again, I was an ops guy, right? And I built networks in the early days and did development, and how much of the time did we spend doing drudgery? Piling through data, trying to find these connections, to try to understand what was happening before we could even begin to assess what we are going to do about it, how we were going to react. What machine learning has the promise to do is to help you eliminate the drudgery, to not have to spend all this time finding the correlation, to expose the correlation to you at the point in which you can do something about it. So it's about faster decisions, better decisions, at the point of transaction, or as close as we can to get there. And that actually means that it's a very promising future. I think the other thing about this is not isolated to IT. In fact, if there's one big reason that you should be paying attention to that, even if you haven't bought anything else I've said so far, is that your organizations are going down this road. I believe we are entering an era of the cognitive enterprise in which organizations are applying these same techniques, machine learning and different forms of AI across the spectrum of the enterprise, using it to drive decision making. And so the question is going to be very, very rapidly as they start doing that, well, and why in the heck isn't IT leading this charge? So if you aren't the chief consumer of data first and foremost, then you are going to be lagging your own organization, the proverbial cobbler's children, which I know we've always kind of been a little bit. But frankly, I don't think it's going to hold water going forward. You're going to have to cross these lines. You're going to have to embrace this because this is the way that organizations are going to be operating in the future across the board. Data-driven, augmented intelligence focused. And in case you don't believe me, here is some data. This is from McKinsey, and I'm not going to go into a lot of detail. Here's the key part. If you look to the far right, these are organizations, pretty much everything from retail and consumer goods to the right. These are organizations that already have 20% adoption at scale. And this is not just testing, this is at scale, that these are industries that are already widely adopting AI. Now, some of these high-tech financial services are somewhat of the usual suspects, but look at some of these. Transportation and logistics, automotive and assembly, consumer packaged goods, right? These are not necessarily the things you immediately think of as highly data-intensive businesses, and yet we are already today seeing at-scale application of AI technologies to solve business problems. So if you aren't seeing this today, the message here is you will. And I'm not going to get a lot into this here. This is also from McKinsey. And this is the way, specifically, that organizations outside of IT are using machine learning today. And you can look at this, and there's some interesting things. But here's the point. Look at the problem types that machine learning is being used to solve outside of IT today. Real-time optimization, strategic optimization, predictive analytics, predictive maintenance, anomaly detection, forecasting. Do those sound like problems that IT operations deals with every single day? These are the exact same problems that IT needs to be leveraging machine learning technology to solve and to move forward into this future. Because failing to do so just leaves us behind. All right, so I've spent most of this time basically trying to make the case for why you need to care about this, why you need to take this seriously, and why you need to understand it. But let's talk about what this actually translates into. Here are the things I think when we talk in the short term, and by the way, I'm not talking even years. I think this is all right now. There are technologies and companies out there delivering this today. This is your augmented future. And I'm just going to kind of go through these at a high level here, but things like operational performance and predictive analytics. You should already be seeing this. This is something that you need to be embracing today, of how do we leverage machine learning to identify patterns and to predict performance, to predict how our systems are going to react under different circumstances, because that data is already there. Now, it does get more complicated because our systems are changing much more rapidly, which is why you need this now. So if you're in retail, you can predict that you're going to have a surge on Black Friday, right? I think we can predict that. But when else are you going to have surges, right? See, that's where we need the data to be able to look at our systems to understand things that we can't predict, because there's very little that today is in fact unpredictable. It's just that we haven't been able to connect the dots to find the data that tells us that A leads to B leads to C. Who here is familiar with the idea of systems thinking? Peter Senge, The Fifth Discipline. Anyone read that book? Okay, so I actually want this answer because I really need to know this. Who has read Fifth Discipline by Peter Senge about systems thinking? Oh my God, okay. All of you go out tomorrow, today, before you leave, and buy this book on Amazon. I have nothing to do with it. I don't know the gentleman. It is one of the most transformational books because it deals with this idea that when we look at problems, we have to be looking at them systemically. And it's this idea. If I take this and drop it, or rather if I tap this, if this is on a table here and I tap this, what's going to happen? I know we're all on these mics, but what's going to happen if I knock this over? It's going to spill, right? Water's going to happen. See, there's a direct correlation. I know the action, I see the reaction, so therefore my brain can connect those dots. But let me ask you this. What if this happened? What if I hit this and then walked away, came over here and was talking, and then 5 minutes, 10 minutes later, all of a sudden, this bottle tipped over? You would probably not make the connection there. You would probably go, I wonder why the bottle tipped over. Was there an earthquake? Was there a tremor? Was there a big gust of wind? What caused it to connect? Because I've become so disconnected from the action to the reaction that I can't connect the dots. As our systems have become so complex, that's what happens. We have an action that occurs somewhere in the system, and the downstream impact of that is apparently unpredictable, but it actually isn't. It's exactly predictable, but there is a connection of dots that occur that we as humans simply can't see because it is too complex. Machine learning helps us solve this problem and helps me get a sip of water. So when we're looking at performance prediction, and really this falls into all these categories, right? That is the problem that we are trying to solve with this, is connecting the dots, looking at things systemically, and understanding the relationship between them. So second major area, workflow categorization and routing. I come from a service management background, ITSM, if you guys have done any work in there, and this has been one of the bugaboos forever, right? An incident happens, whether that's reported by a user or a customer, or whether it is detected through some kind of a monitoring system like AppDynamics, we then have to get it to somebody who can actually fix this problem. And the amount of time and energy that is often wasted figuring out who to get it to, who can solve this problem fastest, is a huge resource drag within IT organizations and really against the entire organization. So again, this is something that machine learning can be used, because once we've given it data that says these are the incidents and this is where they ultimately got fixed, this is where they got routed to, then machine learning can identify those patterns and automatically route tickets based on the data to the right organizations and speed resolution. By the same token, we can use that same data to identify disruptions before they happen. So we saw some of that in the keynote this morning, right? This idea of being able to detect and prevent disruptions because we can identify the markers, the early markers that lead to it. Now, in many cases right now, what we're seeing are very simplistic and technically oriented drivers and triggers. But the reality is that as these systems become more sophisticated, what we have the opportunity is to see much more comprehensive, much more robust patterns, because in many cases, the technical indicator isn't actually the first indicator. There's often a business driver, some kind of a surge in traffic, there's sometimes even an external event. I was actually just talking to another organization not too long ago where we were talking about taking external weather data and inserting it into their machine learning feed. Why? Because there is correlation between changes in weather patterns, the resulting impact to the environment that can affect things like retail store traffic, which can therefore impact performance, right? So the faster I can get access to the data on the weather tells me certain things about how my business is going to operate and therefore the impact of the systems, right? So the more data we feed into these systems, the more we can get ahead of these issues and identify them. Anomaly detection, the same thing. How do we identify something that is in fact anomalous? Do we even know what anomalous looks like? Again, when we're dealing with easy, back in my day, well, we knew what an anomaly looked like because our systems were fairly simplistic. In these highly complex environments where these systems are interacting, and especially when you start going containers and microservices, you tell me what an anomalous activity looks like. It becomes very, very difficult. So machine learning allows us to do that. The last one I want to talk about is this idea of security integration and how machine learning is going to help with this. So one of the areas that we do cover at a certain level is security, and that's mostly because what we see is that security, the ability to effectively strike the right balance in security, is becoming a competitive differentiator for organizations. Because those organizations that can find that balance, which is just secure enough, but not so secure that they lock themselves down and can't be agile and can't adapt to the marketplace, those are the organizations that win. The problem is one of the greatest deterrents to that today is in fact the siloed separation between the security operations and IT operations. I'm curious, who here has a CISO or a security apparatus that is actually completely outside of IT or doesn't report into the CIO today? So, and for the rest of you, how much I'm curious, does anybody have their security operations today integrated with IT operations? A few, that's good. I think that is the future. So I think you guys are actually at the beginning wave of this, because I think that the days of having siloed security and siloed IT operations are numbered. The pace of security, the pace of the impact are simply too great. It is too fast for organizations to be able to respond in time. And so we are seeing that move together. Now here's what's critical about that is that the same data, because security, by the way, is having all the same problems that we just described, that it's all driven by data and it's a massive amount of data. They're having the exact same problem and it's all the same data. There's a reason that Splunk is now one of the largest SIEMs out there, right? And so pulling all this data together becomes critical, and I think that using machine learning to not only massage that and make sense of it, but then use it for both purposes is going to become critical. So what does all this mean, and where do you actually go with this? What do you do with this? And I think there's really three things that you should be doing. The first, and we'll call it four, because I'm going to say the very first thing is to accept this future. 3.5 maybe. You need to accept that this is where it's going. If you don't have machine learning in your environment yet, you will. And even if you do, you've only scratched the surface. It is going to become the predominant force for how operations is managed and run in the very near future. There's simply no other way to do this as the complexity increases. But do not fear it, because I don't believe that that actually results in fewer jobs. In fact, what I actually think is, the net result is this, is that because we're going to take away the drudgery, it means you're going to be able to do more. You're going to be able to manage more systems with fewer people. But the systems, we talked about complexity being good, the systems, the complexity and the depth of those systems is going to continue to increase exponentially. So I actually believe there's going to be continued hiring in IT operations, not less. It's going to become more strategic, not less. And it's going to be driven by the ability to manage these highly complex systems. Those organizations that don't adopt this, that don't go down this road, will therefore create an artificial barrier for themselves. They will not be able to scale and create these ever more complex systems because they won't be able to manage them. And it will hit this automatic break point, and those organizations will then fail in the marketplace. So do not fear it, embrace it. But as you embrace it, there's a fundamental challenge here, and that is that you have to reset your identity. If you right now see yourself as a network admin or a server admin or a sysadmin, whatever, if you see yourself in this technical role aligned specifically to a technology, then this is going to prove challenging for you. So you need to reset your identity to one that is fundamentally focused on how you are helping provide value to the organization and leveraging these technologies to secure those business outcomes. And this is a fundamental cultural shift. If you are a leader, if you have a team, you need to take this upon yourself. There's a good friend of mine who was a CIO at a nonprofit, and he told me the story about how they made a major shift of one part of their infrastructure into the cloud, and it was all related to their database structures, and their DBA, when the project was done, resigned. And he asked him, well, why are you resigning? And he said, I'm a DBA. There's no database for me to administrate anymore. And my friend looked at him and shook his head. It's like, no, this is your future. You need to embrace this. And instead, this guy chose to basically chase something that was no longer going to exist. I'm sure he found another job, but at some point, those roles will simply no longer exist. So it's about embracing your future. It's about embracing what's coming next and resetting your culture to change the way you look at what the role of operations is. And being a former ops guy, I will tell you that it was always my greatest frustration, is that people looked at the role that we had, the job that we did, and they kind of said, well, that's just that, the modern age plumbers, right? And this is such a great opportunity to fundamentally transition that viewpoint, not only externally, but probably more importantly, internally. Understanding how important, and that's because of this last one. Data, as we've talked about a few times already, is the driver in the future. And guess where that data starts? It all starts within the systems that you manage and operate. You need to see yourself as the new keepers of the keys to this new kingdom. The better job you do at harnessing, managing, and leveraging that data to find the things that we don't know about today that can fundamentally change your competitiveness, the competitiveness of the organization in the marketplace, that's where you win. That's where the value lies. Everything is becoming digitized. Everything is being boiled down into a transaction, and our ability to manage those transactions effectively puts you in a really great position as you step into this future. And so I hope that you harness that. I hope that you understand where machine learning plays into that future. You embrace it, you learn about it, you figure out how it's going to be applied, and you step boldly into this future without fear. My last piece of this is to just also remember one last thing, and that is that machine learning is only one piece of this puzzle. I get frustrated when people talk about transformation and they boil it down to any one thing. Cloud, I have a new article for CIO Magazine, I think I'm going to write that cloud is still not transformation, right? That there's a whole bunch of pieces to this, and you need to understand all of them and how they all fit together. Just like I talked about systems thinking being something that was critical to you understand from an operational standpoint, when we talk about digital transformation, we need to understand that it too is a system. In fact, it's a system of systems. And so this is a poster that my partner and associate, Jason, built about a year and a half ago. And it talks about all the different pieces, everything from starting with the customer journey to creating agile architectures to embracing things like big data and DevOps, and of course machine learning AI is all part of that. So you need to understand machine learning in context. You can't look at it in isolation. So with that, I hope you step forward and embrace this and find great success with it.